Hi everyone, I hope you all are doing well. Welcome to day 6 of Array and String Mastery series at Arush Coaching Classes. I hope you all have been enjoying till here. The questions that we have discussed already, the things that we have learned. So today yesterday we covered the sliding window pattern questions. It was more around size sliding window. Today we are gonna work around variable size sliding windows. Okay, so let's first try to understand what it actually is. So, as the name suggests, like variable size sliding window, correct? The name itself is quite much self-explanatory. Variable means which can change, correct? So that's why here the windows that can grow and shrink dynamically. Okay, according to the requirement, they can be grown and shrinked as well. Okay. Would be size changes based on problem conditions. So obviously, on the basis of the conditions, on the basis of the requirements, we will be increasing or decreasing or growing or shrinking the window size. Okay. More flexible than fixed size windows? Yes, because according to the problem statement, wherever you are needing to apply some solution which requires this kind of condition to flexible window size rather than fixing the size of the window. Okay, so that's where we use it. Perfect for optimization problems. Yes, definitely it is, and we will see more about it in the later part of the lecture. So about the analogy, how you can remember it in some short term, you can think of a rubber band that stretches. Like you must have seen a rubber band of size this, correct? But when you stretch it by putting one side here and putting one side here, once you stretch it, the size will become like this, correct? But it does not mean that it is the only size it can attain. It can attain this much size also. Completely depends upon the capacity of the band, but yeah, it can be grown little more, as well as it can be shrinked till here again, and till to its original shape as well. Okay, so you can think of a variable size window more like a flexible rubber band whose size can be either grown or shrinked according to our requirement. Okay, now just basic hints or more like some terms for you to remember this when to use. So you must see problem solving is all about recognizing what is actually being asked in the problem statement, how or what it is related to what you have learned already. Okay, so there must be some keywords that you can identify and fix your mind to struck some idea like what can I use here or what can I do here? Is there anything that I have learned already which was using it earlier? So for those words you can find like in the problem statement if it is written finding longest or shortest subarray satisfying some condition. Okay, then you can probably think of. I'm not saying definitely this would be the solution, but I am saying that probably this will give you some pointers around what you can not think about. Okay, what you can filter out already. So some basic things you can filter out that won't be applied here. Here you can either think of कि sliding window तो लग रहा होगा कौन सा लगा होगा, either it can be fixed or variable. So that's what you can think about. Okay, now problems with at least and at most. Okay, so at least and at most, these are the words which are not very definite, है ना? Not definite or exact. You can understand that, correct? Means at least में कम से कम, है ना? Starting from somewhere, but it can grow. At most also, that's thing, है ना? कि किसी पॉइंट से आ रहा होगा, इससे आगे नहीं जा सकता, तो इसके इधर तो जा सकता है, बट ये यहाँ से स्टार्ट होगा इसके आगे तक जा सकता है. Okay, so that's what these words tell you. Exactly, at exactly also, that is a window, but it can give you the feeling of कि होता है fixed जो, correct? So these are the words that you need to focus upon. That's what I'm saying all about. I'm not saying this is gonna be working for sure, but I'm saying what to not think about, correct? When window boundaries need to move independently. Okay, so these are the pointers, or you can say identifiers in your mind mapping world, okay, where you can think of, or once you understand these words, once you figure out these words in the problem statement, then you can probably think of the solution in this direction. Okay, so let's move to our first problem statement that we are going to discuss today. Longest subarray without repeating numbers. As the name suggests, longest subarray is what we need, but the constraint or the condition is without repeating numbers, you know? Or in short, I can say longest subarray with unique numbers. है ना? That's what I can say. So the problem statement would be telling you find the length of the longest contiguous subarray, length of the longest contiguous subarray where all elements are distinct. Okay, this is the most shortest version of the solemn statement to be talking about. Okay, otherwise in the real world you'll be getting a whole paragraph, है ना? लंबा चौड़ा paragraph मिलता है. You need to read it, you need to understand it to figure out that that question was asking for nothing but this thing only, or at least a version of this solemn statement. Okay, so let's quickly move towards the input or the sample examples. Okay, so simple case एक हो सकता है इस एग्जांपल का क्या, one array is given to you and here the you can see the output is 5. Why? Because the longest unique subarray is, well, I mean, as you can see here there can be multiple subarrays, है ना, multiple longest unique subarrays. You just need to tell what is the size of that subarray. Okay, so if you are getting this, then don't confuse कि answer नहीं हो सकता. This is also the answer, but in this particular problem, they are asking you to give the length of that longest unique subarray. Okay, not all the subarrays. ठीक है. So let's have a quick view of how we are identifying it or how we are reaching to the solution. So the numbers are 1, 2, 3, 1, 4, 5, 2, and 3. 4, 5, 2, and 3. Indexes would be 0, 1, 2, 3, 4, 5, 6, and 7. So from here you can see that if I start my subarray from here, okay, so the number of unique items would be 1 because 1 is unique till here. If I move further, then 2 is there. So 2 is also unique, so size would be 2. If I move further, I will reach to index 2, which is item 3. It is also unique, so size would be 3 or length would be 3. If I move further, I will reach to 1, means index 3 item is 1. It is not unique anymore. For this particular subarray, starting from 0th index till 3rd index, you can see that this is getting repeated. So till here, what was the maximum length? 3 था, ठीक है. अब मैं क्या कर सकता हूँ? अब मैं क्या करता हूँ earlier, because we have already seen how do we generate subarrays, है ना? Let's think about the most naive approach, है ना? Because our intention here is to just get the solution, है ना? So in that way only, let's try to understand this. So what will I do? I will start from next index. I will start creating my subarrays from next index. ठीक है, अब 2 से start करते हैं. From 2, the 2 is unique, okay, first item, and length would be 1. So earlier, till in the very first subarray, we have already got the maximum length was 3. So 1 won't be updated, है ना? अभी इससे कुछ बड़ा ही चाहिए, then only we will be updating what is the maximum length. If I move forward from 2, I will reach to index 2 and item 3. 3 is also unique till here. So length would be 2. Move forward, I will reach at index 3, item is 1. 1 is also unique from here till here, correct? So that's why length would become 3. Now, if I move forward and reach this fourth index, item is also 4. So till here, what I have seen, 2, 3, 1, and 4. So 4 items all are unique, so length would also be 4. Now this time, because this 4 have exceeded the previous 3, so maximum length would exceed to 4. है ना? Not just exceed, it would be updated to 4. Next, I will reach this item. Okay, this item is index 5, item is also 5. 5 is also unique till here, so length would be 5 and max would also be 5. Okay, after that I will reach here. This is index 6, item is 2, but 2 is not unique for this subarray. So what will I do? I will stop, है ना, बस यहीं तक था, and यहाँ तक हमें 5 items मिल चुके हैं. Okay, then I will again start my survey from the next item, from here. From here also what I can see, 3 is a unique item for the starting, so 1 length हो गया. I move forward to index 3, item is 1, so 3 and 1 again unique, so length 2. Okay, next item is at 4 index, item is 4. Okay, this is also unique, so 3 हो गया length from here till here अभी तक. Then I will move and I will reach 5 with 5 index. Okay, 5 is also unique, 4 कर दिया. Now I will move again, I will reach here. What I am getting, 3 1 4 5 done till here, then 2 is also here, है ना. तो अभी 2 पे क्या आएगा, एक और आइटम का 1 2 3 4 5, so our length would be 5 and we can see last में 5 ही था, तो अभी कोई अपडेट नहीं है. Okay, once I move forward, I will come at the item 3. See, this is the beginning, है ना? So it is getting repeated, so I will stop here. So till here also I am getting only 5 length only. As I told you earlier, there can be multiple such subarrays where the maximum length of the items can be same, है ना? जैसे यहाँ 5 है, यहाँ 5 है. We have found one more subarray, 3 1 4 5 and 2, है ना? 3 1 4 5 and 2 also would have the longest unique items. Okay. Next, we'll start from new subarray. So my idea is for subarray, we are checking how many contiguous unique items and storing the maximum length and storing the maximum length of that. So that's what the approach is gonna be. Okay, that's what the approach is gonna be. Here also you can see other cases, like this was a simple case. There can be a case where all the items are unique, so whole array length would be the output. There can be a case where all the items are same, so only one length is possible. There is a mixed case as well. This much long this subarray is, यहाँ पे continuously you will be getting redundant items, so you will figuring out continuously similar to the first case. Then you will get the output as 8, like 3 4 5 6 7 8 1 2. This much is the contiguous unique item subarray. 1 2 3 4 5 6 7 8, 8 items, that's why it is 8. Because if you can see 1 2 then 4 repeated, so till here 3 only, and 2 4 4 again 2 only, 4 4 4 only. Okay, then 4 5 6 7 and 8, and then 3. How many items? 1 2 3 4 5 6. Okay, then 4 again, no, it is repeated. Similarly 5 again repeated, 3 again repeated. So this is the subarray which we are getting in the output, okay, which have continuous 8 items which are unique. Okay, and the approach would be same. For subarray we are checking, or you can say for every subarray we are checking how many contiguous unique items and storing the maximum length. Okay, so let's move towards the brute force approach. So what are we going to do here is, you can see here, check every possible subarray and verify if all elements are unique. We need to check every possible subarray and verify if all elements are unique. And accordingly, we will try to store the subarrays, okay, or the length, their lengths, okay. So let's see here. Let's have a quick understanding, because as I told you, we will see for all the subarrays, correct? So let's see and check. Input is 1, 2, 3, and 1. First, tell me quickly in the comment what is going to be the output for this. So obviously, there are these 3 unique items continuously. So output would be nothing but 3. Okay. So if I start generating my subarray from the 0th index, okay, from this index 0, item is 1. So if I start from here, 0th index, so first item is unique, so length 1, and maximum length would also be 1. Okay, done. When I move from here to here, है ना, अब 2 पे चले गए. Then index 1, item is 2. 1 and 2 is in my subarray. It's still unique. So length would be 2 and maximum would be 2. I move to next index, which is the second index and item is 3. So here also 1, 2 and 3. So unique, all of them, length would be 3 and max would also be 3. Next item, third index item is 1. But here in this subarray, you can see that if I include this, there's a duplicate. One is duplicate. So I would stop checking for the subarray starting from the 0th index. क्योंकि अब इसके आगे कुछ भी जाऊंगा तो 1 तो repeat हो ही रहा है. Anyhow, if I move forward, let's see here there were more items. If I move forward for a subarray starting at 0th index, then I am not gonna get all the unique items because one is already getting repeated here. So that's why I will stop checking from here. Until here, the maximum length was what? 3 only. Okay. So what will I do next? I will now start my subarray from where? Obviously. First I started from 0th index. So now I will start from first index. है ना यहाँ से start करेंगे. If I start from this very first index, then what will be happening is just a second. If I start from this index, index 1, then item is 2. So very first item is 2, it's unique, length 1, max 3. Then I will move forward from here. Index 2, item is 3. Okay, so 2 and 3 both are still unique. So maximum length right now is 2, but max was 3, so no updates. Okay, now I will go to next item, which is the last index. Item is 1. 2, 3, 1 is still unique. Okay, so length would be 3 and max is still 3. No updates. So now we can see that 1, 2, and 3 is a subarray, and 2, 3, and 1 is a subarray where we are getting the maximum length. है ना? Okay, all the items are unique and it is the longest subarray. Okay, now after exploring this, we will do what? We will go to the next index and start generating our subarray from there. From 3. Okay, item 3 index is 2. So index 2 say if I start, first item is 3, length is 1, max won't be updated. It will still be 3. Next item is at index 3. यहाँ check कर लिया. Next item is index 3, item 1. So 3 and 1. Two items, but length would be 3. No changes here. Okay, so this array is completely explode. Now I will move to the next item, last item, and I will start exploring from here all the subarrays. So this is only one item, unique, length 1, max won't be updated, it will still be 3. Okay, so after this there's no more item, so I can't generate more subarrays, correct? So till the end, what I'm getting is my max value was 3 only, so that's why output was 3. How about writing the code for this? As you can understand, I am generating the subarrays, and with every generation, I am just checking the unique and length, these two things. So what I can do is, for uniqueness, if you remember from the last session also, what we were using? What we were using? We were using set, है ना? Uniqueness के लिए, ठीक है? Length तो हम ऐसे भी calculate कर सकते हैं, and we were the track of keep track of max length, है ना? That's what we need to focus upon. Okay, so let's see कि क्या solution था इसका. Okay, so the solution is here. Longest unique subarray. The array is given to you. I am taking a variable named max length to track the maximum length found. Initially, I am just putting it at the value as 0. Okay. After that, what I am doing is try every possible starting point. Obviously, I am trying to generate all subarrays. You know, all subarray. So what I am doing is starting point for fixed करने के लिए I am putting a start variable. Start equals to 0. Start less than nums dot length. Start plus plus. Okay. This is for the first outer loop. Now, to keep track of this uniqueness that I was talking about, what I'm gonna do is I'm gonna create a set, okay, or you can say hash set to track unique elements in current subarray. Unique elements in current subarray because I am going to generate subarray inside this for loop, and using this loop. So that's why I'm first creating a hash set. Now, which is gonna take the integers because all the items of this array are integers. Now, expand subarray from current start point. So current start point would be nothing but the the outer loop's start point. And so that's why end is equals to start we're starting with, end is less than n, and plus plus. Okay. Now current number equals to nums end. Why? Obviously, if I am starting from here, so current number would be this one only. So that's why nums and is also pointing at same, because and is the iterator that we are going to use to generate the sum. Sorry, subarray. है ना? So we have taken the current item, okay, number nums and मिल गया. यहाँ क्या होगा? 1 मिला होगा. I have taken 1. Check if current number already exists in the subarray. So if current elements dot contains, because my set name was what? My set name was current elements. है ना? So that's why in this set I am checking my current number. If it is present, if it is true, okay, so I will break. Why? Because if a duplicate is found, then no point expanding further, which I showed you earlier. Na? From till here in this subarray, when I encounter one again, though irrespective of the condition that there are too many items 5, 6, 8, 9, there is no meaning in traversing further. Why? Because if I make this long subarray, one is still gonna repeat. So I need to break from here and go to the next possibility of the subarray instead of extending it further. That's why when you find a duplicate, no point expanding further. All larger subarrays from the start will also have duplicates. So that's why you will be just breaking from the internal for loop which is generating the subarray right now from the same point. We'll change the starting point after that. But before that, what we'll do, we'll put current item. Okay, not before that. If the item is not duplicate, है ना? अगर item duplicate नहीं है, let's say for one it was not duplicate, है ना? So what will I do? Current elements dot add means जो current element का set है, will put one there. Okay, I will put one there. This line would be doing that. Next, current length would be what? So for this subarray, where I have found a unique item, okay, what I am gonna do? Find the length. Length would be n minus start plus 1. So length is 0 minus 0 plus 1, which is nothing but 1. Okay. And max length? Max of max length and current length. Hope that you are quite much familiar. Hope kya? I am very sure because we have been discussing it since our very first session, I think. Okay. So this is the basic logic of finding maximum among two items by comparing it. And for that you can use this inbuilt function math.max. So max length we already initialized as 0. Current length is 1. So what would is the maximum? 1 of course. So it would get updated in this variable. So max length क्या हो जाएगा? ml would be 1 now. 0 से 1 update हो जाएगा. Okay. Then this loop would be over. ये जो internal for loop है. And then we'll do what? Then we will move towards the external for loop. Here again, what will be happening? Start plus plus. So start would move to this position. And from here we will be doing the same thing. I hope I have already shown you this particular, I mean the whole idea and the dry run, how this is gonna happen. So you can dry run it completely on your own time as well. So this is how you're gonna get this output. Okay. So now tell me quickly, what would be the time complexity for this? The time complexity would be what? Time complexity would be big O of n square. Why? Obviously you are generating subarrays, you know. So that's why. And space complexity would be what? And I mean, checking the unique item doesn't take much. Why? Because this is the only thing where you're checking for unique item, you know, and it takes a big O of 1 because you're using a set and a hash set use किया है. So looking in this takes order of 1. Even adding in the set also takes constant time. So that's why big O of n square only. Now about this space complexity. So because you are using an some extra space which is this set or hash set, so when worst case would be big of n when all items in array are unique. In that case, the size of this extra space which is being used for this set would be equal to the size of the actual array. Okay. So that's why the time complexity would be big of n square. Space complexity would be big of n. I hope this is clear. And at the end, we are just returning maximum length. Okay. So let me repeat why this is inefficient. Because we are doing repeated work. What is a repeated work? If you see this dry run correctly, है ना? Look at this. When we were exposing all the sub arrays starting from the zeroth index, we generate what? 1, 1, 2, 1, 2, 3, 2, 1, 2, 3, 1. Till here, we knew that 1 and 1 are duplicates, and before this step, we knew that 1, 2, 3 are unique. Still, when we moved our start point to index 1, we again generated all the subarrays 2, 2, 3, 2, 3, 1. If you see 2, 3, we already generated, we are generating again. 2, 3, 1, we already generated, I mean, worked upon, and we are again generating and working upon it again. So you can see too much of the repeated job is what we are doing here. Same for the next sub array. 3 generate किया ही था. Sorry, 3 1 generate किया ही था यहाँ पे. Again we are generating 3 1. Yes. So that's why it is quite inefficient. Sub arrays 2 3 and 2 3 1 are checked separately. Though it is more like a repeated task. Repeated task. Remember, why did we require the sliding window idea in the first place? If you remember the last class, we saw that there were too much of the repeated task happening already. So to avoid that, we were using the pre-calculated results in the next step. Okay, so that's why we use a sliding window. So here also you can see the same pattern that repeated task is happening here. Okay, now no memory does not remember that 123 was valid when starting from position 1. We don't remember the previously calculated results. Okay, that's why we can't reuse it. Can't reuse previous results. That's why recalculating. Yes or no? That's what is happening. Now, early break helps still big of n square in worst case है ना. Worst case में big of n square ही जाएगा क्योंकि आप सारी आइटम जब यूनिक हो जाएंगे तो आप चेक कर ही जाओगे. Repeated calculations would be there. Time n square space order of n. Okay, which is being used by the hash set for each starting point. Now moving towards some giving you some insights, brute force versus optimal insight. What is that? So what's wrong with brute force? First, redundant check. We have talked about it already. Next, starting over. Obviously, to do the redundant check, we are starting over and over again. है ना? वापस से वही काम कर रहे हैं. No information reuse, as I told you earlier. Here, can't reuse previous results. That's why recalculating. So that's why this is one of the major problems. No information reuse. So we don't remember that one was at position 0. So when we see one at position 3, we have to scan to find a duplicate. Correct. That's why. Optimal side क्या होगा? Instead of checking every subarray from scratch, maintain a sliding window and use hash map. Maintain a sliding window and use hash map to remember where each number was last seen. Okay, this is more like a memory of last seen, which you want to utilize in solving this problem. Okay, so when we encounter a duplicate, we can instantly jump over it. That That's what would be our advantage. So how we can get this advantage or achieve this advantage? Let's see. Okay. So let's see quickly. So thought process and strategy would be we are gonna use a hash map. We are gonna use a hash map to remember the last position of each number. When we see a duplicate, we can jump the left pointer to position after the duplicate's last occurrence. Let me show you. Okay. Like, let's see if I started from here. Let's see if I started from here. Zeroth index 1, 2, 3, 4, 5, 6, and 7. If I started from here, let's say I covered 1. ठीक है कर लिया in my subarray. Then I covered 2 in my subarray. Now length would be 2. ठीक है. Still unique. I covered 3 in the subarray. Still unique. So 3 कर दिया. When I reach 1 है ना, तो what I will see? I will see that somehow use a hash map to remember the last portion of each number. So 1 की last portion क्या थी? I will see I was getting 1 at 0th index, है ना? 0th index. So what will I do? Because I can move forward while making my subarray a little bit longer or expanding my subarray, but I can't do unless I get rid of this one. Because if I move further, whatever long distance I cover, or however many items I will get in my subarray, that subarray starting from 0th index would still be not unique. Yes, yes, right. So that's why what you can do is last position of each number. So here we found the last position of 1 was 0th index. When we see duplicate, we can jump the left pointer to position after the duplicate's last encounter. Position, we can jump the left pointer to position after the duplicate's last occurrence. ठीक है, जो लेफ्ट पॉइंटर है यही था, राइट पॉइंटर आपका ये था. ओके. So what do we need to do? We need to jump our left pointer next to the last occurrence of the duplicate item. Duplicate item is 1, last occurrence is at 0, so next we move करेंगे, so we will move our left pointer here. Now we can see that L is marking the start of the subarray, R is marking the end of the subarray, and from here till here, let me change the color, from here till here, index 1 to index 4, all the items are unique, 2, 3, 1 and 4. So, sorry, just a minute, I think jumped one more item. Actually, we were working at the index 1, sorry, 3 only. Why? Because the item 1 was repeated. Na, abhi to R yahin pe tha, not here. Okay. So here, what are we are going to do? Till here, we just marked the, or you can say discarded the repeated position. Okay. And then we will do what? For this one, because we are taking it in our current subarray, we will mark its last position now as 3. Okay. Because we need to update for further use. अब तो इसको भूल जाओ. This is forgotten now. For this particular subarray, this is forgotten now. Because this was a irrelevant information. I will move forward. I'll come here. My R will come here. Index 4 item is also 4. ठीक है. 4, it was not in my set. Hash map है ना. तो length 4 हो गई. ठीक. And 4 को हमने hash map put कर दिया होगा. Next, we'll move forward. 5. 5 also unique. So length is 5. Next, we move forward 2. 2, we have already 2 है ना. Entry तो 2 का भी रहा होगा because we are using hash map. So 2 का last index क्या था? What was the last index of 2? 1 था. 2 का first index था. So that's why what we will do? We will put our left pointer next to 2. Next to 2 would be 3. है ना? Item is 3, index is 2. So here, and we'll update the occurrence index of 2 as 6. इसको first से 6th कर देते हैं because it is at 6 index. Till here, what is the length? अब क्या हो रहा है? Our sub arrays from here till here. है ना? अब यहाँ से यहाँ तक है. How many items are there? So 3, 1, 4, 5 and 2. 5 items are there. Okay. So still the length is 5 only. 2 को हमने update कर दिया. Next we will move forward with our eye pointer. Here 3. 3 क्या हो रहा है? Repeat हो रहा है. Okay. What is the last index of 3? Last index of 3 was at the 2 second index. So I'll put my left pointer next to the second index, which is gonna be here. Now I can see that my effective subarray is from here till here. How many items are there? 1, 2, 3, 4, 5. And 3 का index क्या update हो जाएगा? 7th हो जाएगा. So still the length is 5. So that's why the output would be 5. And from here we can see that there is no further item to traverse. In just single traversal and both left and right pointers combined, we are traversing whole array at max twice of n times. ठीक है, यही हो रहा है. In case all the items are same, so in that case you will see both left and right would be traversing the whole array, so choice of n ही होगा वहां पे. ठीक है. So this is what the idea is, and about showing you variable sliding window, correct? So as the sub array grows, what did you saw? Sorry, what did you see? Left pointer was fixed, right was moving, you know. L was fixed and R was moving. This implied that window size was growing. Okay. And when left was moving and R was fixed, so what was happening? Window size was shrinking. Okay. So that's what exactly was happening. Okay. And about if you are still confused about this, how did you remember the last index? So with every item I am traversing, I am using a hash map to store item as key. क्या होता है की वैल्यू पेयर होते हैं करेक्ट तो item as key and items index as value. Okay, that's what I'm doing. Let's see here very quickly what is happening. है ना यहाँ देखते हैं. Let me just write the array first. What is the array? 1 2 3 1 4 5 2 3. 1 2 3 1 4 5 2 and 3 was the array size. Okay, this is the array. 0 1 2 3 4 5 6 and 7 was the items. Okay, and output was 5. So now you can see that output is 5. I know. Now you can see that here clearly. I am putting my right pointer where right equals to 0. Okay, right यहाँ पे मेरा ठीक है. Left is also 0. Left is here. Okay, current number is 1 है ना. Current number cn equals to 1 है अभी. Last seen is the set है ना, or you can say hash map. Hash map, you can see curly braces. This is for the hash maps or can say dictionary. Okay, last seen ls कर देते हैं. अभी empty है. So what we are doing, initially it was empty, but because I am at this index 0 and item 1, I have seen it. So I'll store what? 1 colon 0. Why? 1 is the item, 0 is the index, as I showed you earlier. यहाँ क्या था? Key value pair is what we are storing in the hash map. Key is the item is the key, and index is its value. Okay, that's why for 1 as an item, we are storing 0 as its index. So till here, the maximum current item length is 1 and maximum length is also 1. Okay. Window size क्या अभी window में 1 ही है because left and right are pointing at the same item. So window size is 1 only. Step 2. After this, I will move my right pointer here. है ना यहाँ move कर दिया. Now here my current number is 2 and in the last scene I can see that 2 is not available. So what will I do? I will put 2 here because if it is not available here as the key means it tells me that 2 is still unique. So I will put one more value here, 2 colon 1. Okay, and after that what will I do? This is done. Left is still 0 है. Left तो वहीं से चालू हुई था. ठीक है. Current length क्या है हमारा? What is the current length? Current length now is 2. Okay, current length is 2. Why? Right minus left plus 1 कितना होता है? 1 minus 0 plus 1 equals to 2. Okay, that's why. This is 2. Maximum length would also become 2 and window size is 2. Why? Because you can see 2 items are there. Okay. Step 3. Because I have not found a repeated item yet, so I will keep moving. 3. 3 is also not in the map. So what will I do? 3 comma 2 would be the, sorry, 3 colon 2 would be a new entry here. Now, what? Because I have make an entry here, so I will include my length also. है ना, current length कितना हो गया? 3 हो गया. Right minus left plus 1 कितना आएगा? 2 minus 0 plus 1 3 आ जाएगा. Maximum length would become 3 updated and window size is 3 because you can see till here our window is growing. Okay, our window is growing. Next, we are coming to where right pointer को move किया, and then here what is happening? We have encountered one. We will see, है ना? हम check करेंगे at this first step. One is duplicate. Why? Because we already have an entry starting with one in our last seen hash map, है ना? तो duplicate हो गया. So what will I do? I will put my left pointer where? See, last scene में मिल गया है. So last scene contains one at index 0 which is greater than equals to left 0. Obviously, though I have an entry with key 1, है ना? So again I need to check if it lies in my current window or not. How to check that? Then its index should be greater than or equal to my left index, है ना? Left pointer यहीं तो बैठा है. So that's why I am checking which is greater than equal to left, which is 0. So left is equals to left को आप कहाँ भेजेंगे? We don't want left to go in the backward direction. That's why we are keeping one more formula here. Max among left's current value and duplicate items index and left plus one, है ना? Duplicate item plus one and left value. Okay. So which one is maximum? It is one. So we will put our left there. So we are putting left here. Okay. And last scene would have what? Because one is already entered there, so we will update its index value. What is the value of its index? 3 है. So 0 से हट के यहाँ पे 3 आ जाएगा. Okay. That's how things are gonna happen. You can see here. So current length would be 3 minus 1 plus 1 is 3. Max length 3 है and window is 2, 3, 1. Now in the window, what are the items? These are items 2, 3 and 1. Okay. ये 4 and 5 तक भी जाएगा. That's how we'll get the 5 window. Then 2 repeat होगा, same thing would be happening. Then 3 repeat होगा, same thing would be happening. Okay, I hope I have shown you enough, है ना? And at the end, once this whole traversal is over, my window would have what? Once I have at the index 7, है ना? जब तक पहुंच जाएगा, window would have 1, 4, 5, 2 and 3 only. Maximum length would be 5 only. And you can see all the indexes have been updated as well. Okay, why I'm not showing all the try because it is little lengthy. I want you to do it on your own also. You can take 5-10 seconds and to run it on your own also. See, code comes the last, है ना? First, because you might be thinking that why the code is not shown, what I am doing, why do I need to do in this step? Because these whole steps build your thought process, है ना? If you are able to formalize your solution in words, है ना? कि क्या कर रहे होगे exactly, and if you can visualize it in this way as well by working upon the array directly, then writing code becomes easier, है ना? कोड लिखना फिर बहुत easy हो जाता है. कि कोड कम्स लास्ट, पहले आइडियाज आते हैं. You cross check you validate the idea by cross checking through some dry run and then only you write the code. Okay, don't jump to write the code directly ever. So here we are given with the array. We are creating a hash map to store the most recent index of each number. Key would be the number or item and value would be the last seen index of that item. Okay, so it is created, named as last seen. Left pointer is initialized to 0. Max length is initialized to 0. Now, we are gonna put our right pointer to the starting point as a left and then we will expanding the window. Okay, so this for loop is doing the same thing. For int right equals to 0, right less than nums dot length, right plus plus. Current item is what we are storing. Okay, from taking the right index. Now we are going to check if current number is already in our window. How to check? Obviously, we will check using last in dot contains key in the current number. Current number is nothing but our hash map, है ना? ये कुछ और नहीं बल्कि अपना hash map है, where we stored the items as key and value pairs. Okay, so that's what we are doing. Last in dot contains key. What is that key? The number at the right index right now. ठीक है, वो check कर लिया because इसमें store किया था. If it is there, then it will become true. One हो गया. And operator, then this all condition also needs to be true, then only we will move inside, है ना? So देखते हैं. Last in dot get current number. Okay, get will be giving you the value. Okay, value associated with the key. Okay, it gives you value associated with the key. And if it is greater than equal to left, then only you will work upon this कि हाँ अपने विंडो में है. It means that duplicate item is in current window. Okay, that's what this means. Duplicate found, move left pointer to position after the duplicate. We use math.max to ensure left never moves backward. Okay, that's why this max function is being used. Otherwise, you could have done it directly. So left, comma, last in dot get, उसका जो भी index है, उसके next put करना. That's why plus one is happening there. Okay, plus one is happening to do what? To position the left pointer after the duplicate. That's why it is happening. Okay, now that's how the left would be updated. Now, what are we doing? Update the last is in position of the correct number. अब तो कर दिया, duplicate find करके ये काम भी कर दिया. We need to update the last is in because I need to update it according to my current window. That's why I'm overwriting its value, है ना? So put, है ना? Enters, I mean puts an entry और overwrite. यहाँ पे overwrite का सीन है because key is already available. Okay, overwrite in hash map. ठीक है. Now calculate current window length. Obviously बहुत easiest part है. Right minus left plus 1. That's how you calculate the length of the window. Then max length को update करना है. Math.max max length comma current length. This will update the max length of the maximum window. Okay, and once everything is over, we will just return the max length variable. Okay, whatever value was given there. Just have a good look again at the code, and I will really appreciate if you can run it on your own. Because see, once you build the idea, once you have, I mean, justified it, cross-checked, validated it, then you write the code and then you run it again to see what is missing from the idea that you were thinking of. You know, I mean, if there is a gap between the idea and the implementation, you will get it right. Okay, so that's why you need to do it. Now, if I talk about the time and space complexity, what is the time complexity here? The time complexity would be what? You can see if one for loop is used here. Okay, though we're using two pointers and left right pointer is used in the for loop, left pointer is used for the duplicates. Okay, so if there all the duplicates item, worst case क्या हो जाएगा? Worst case big O of twice of n हो जाएगा. All same items है ना, अगर ऐसा होता है तो. So again twice of n को हम क्या लिखते हैं? Big O of n only. That's why the time complexity would be big O of n. But what about the space complexity now? Space complexity because you are using hash map है ना, worst case में कितना space लेगा? Big O of n when all unique items. So n items, they are unique, so n entries would be there. Okay, n unique items, all unique items. In that case, space complexity would be maximum big of n. Okay, now let's talk about this. Time complexity, we traverse the array once with the right pointer big of n. Okay, each hash map operation put get contains keys order one on average, so it is constant. Okay, next, even with duplicate checks, each element processed at most twice only, nothing else. कितना भी duplicate होगा twice या नहीं होगा. That's why big of twice of n ही था, and that twice of n can be written as big of n only. Now space complexity, minimum of n comma m. Why? See, n is the array length. Okay, m is number of distinct elements. So जो भी minimum हो वो कह सकते हैं. But if n sorry m is equal to n, all unique elements है ना, तब क्या हो जाएगा? n m जो है n के इक्वल हो जाएगा. That case that's why big of n is the space complexity. Best case में तो सारे सेम है तो फिर तो एक ही आइटम आएगा. But we always talk about the worst case है ना. That's why we don't need to focus upon here. You need to work upon here. Okay. So now let's see. अप्रोच क्या था? ब्रूट फोर्स में बिग ऑफ एन स्क्वायर टाइम था. स्पेस वॉज बिग ऑफ एन फॉर द सेट है ना, हैश सेट यूज किया था. स्मॉल एरेज ओनली पे ये काम करता है बिकॉज टाइम इज ऑफ द ऑर्डर ऑफ polynomial, ठीक है. But with sliding window and hash map, time becomes linear. ये बहुत significant reduce करता है. I will show you in the later part of the lecture how significant. Okay. Next is order of n and all cases. Spaces order of n, and for all cases you can use this. Okay. Next, coming to the next problem. Why I tell you this or explain the whole thing in one go? Because I want you to not lose the momentum. अभी एक समझा है ना, अभी ताजा ताजा है, ठीक है, बहुत फ्रेश है दिमाग में, ठीक है. So let's apply it right now. Otherwise, if you take a break, you might forget something about that, है ना. So push yourself a little. That's why. So let's see next problem. It is quite similar, very, very similar. It's just that, but for the people who are completely new to this, they just need to first understand the pattern. Pattern समझने का ही time है, otherwise rest is completely same, है ना? Not exactly, but mostly. So let's see. Let's read this problem statement again. Find the minimal length of a contiguous subarray whose sum is at least target, है ना? At least target. So here the keyword you need to focus upon is minimal. Minimal का meaning क्या होता है? Can't be smaller than this. But at the same time, they're saying minimal length का contiguous array चाहिए whose sum is at least target. At least मतलब greater than or equal to target. Okay. Sum is greater than or equal to target. That's what they try to say. है ना. तो देखो, initially I told you ना, there are some pointers which give away the hint of what you need to, at least which direction you need to think in, है ना. So at least यहाँ लगा हुआ है, minimal length भी लगा हुआ है. So let's try the sliding window, है ना. क्या कर सकते हैं, वो भी क्या करेंगे, ग्रेटर इक्वल टू लगाओ, मतलब वेरिएबल होने वाला है, ग्रो भी करेगा, श्रिंक भी कर सकता है. सो लेट्स सी. सो स्टैंडर्ड केस क्या है इसका एग्जांपल का. So let's say you are given with an array having 2, 3, 1, 2, and 4, 3. 2, 3, 1, 2, 4, and 3. And the indexes are 0, 1, 2, 3, 4, and 5. Okay, let's have a look. Target is 7. Target equals to 7. Okay, so let's see. एक बार sum देखते हैं. 2 first item plus 3 plus 1 कितना हो रहा है. फर्स्ट आइटम का सम 2 ही है. 2 एंड 3 का सम 5 है. 2 3 एंड 1 का सम कितना है. 2 3 1 6 हो गया. देन 2 3 1 and 2. If you are wondering what I am doing, then as I told you, it is quite similar to the previous problem. क्या कर रहा हूँ मैं यहाँ पे. We are talking about contiguous subarray. Am I exploring subarray or not? Contiguous subarray? Yes, I am exploring the contiguous subarray starting from this index. Okay, and I am continuously checking for the sum also. So अभी sum कितना हुआ 6 के बाद. 2 3 1 and 2 again. So कितना हो गया. 8 हो गया. And if I move further, 2 3 1 2 and 4 भी आ गया. तो अभी कितना sum हो गया. 12 हो गया. So do I need to look any further or not even this, है ना. क्या 8 के बाद ही मुझे और देखने की जरूरत थी. Even after 8, did I really need to look after this item. इसके बाद क्या देखने की जरूरत थी. Because my target was 7 and sum is 8, so it has already exceeded, and previously sum was 6, means I can't get a contiguous subarray whose sum is at least 7, है ना. 8 तो मिल ही रहा है. 8 तक ही मैं यहाँ पे अब खुश हूँ, क्योंकि 7 से जस्ट ऊपर हो गया ना, greater than equals to. If I go any further, I will get the sum as 12, है ना. But that's not the minimal length. इससे छोटा नहीं होता. Because here what is the length. Length equals to 3. Here what is the length. 4 है. क्या मैं, and let's say 2 3 1 2 and 4, this item also let's say include कर लेते हैं. Sum was 12. What is the length. 5, है ना. 1 2 3 4 5. When I talk about minimal length, minimal length means can't be smaller than this while satisfying this condition. Sum is greater than equals to target. Here's my sum is greater than equals to target. Why? Because 12 is greater than equals to 7. True है. But is it minimal? Is this minimal? Can't I have a smallest subarray whose sum is still greater than equal to 7? Yes. Why? Because just previous to this we have seen that this is 8. And now this is 8, the length is 4. 8 is greater than equals to 7? Yes, it is. Yes, it is. And the length is 4. 4 is less than 5. तो क्या कह सकते हैं? This can't be the answer. है ना? Minimal नहीं, not minimal. Not minimal. Okay, एक और देख लेते हैं. Let's see. अगर इसके पीछे भी आते हैं. You're thinking सर ये भी तो चेक कर सकते थे. So, what is the length? 3. Sum is 6. Is 6 greater than equals to 7? False है, नहीं है. तो जो फर्स्ट ट्रू है ना वही मिनिमल है, उससे छोटा पॉसिबल नहीं है सम के इक्वल, सम से ग्रेटर देन इक्वल टू नहीं है, एंड उससे बड़ा तो वैसे भी लेंथ बढ़ जा रही है, सो इट इज ऑफ नो यूज. सो हियर स्टार्टिंग विद द वेरी फर्स्ट आइटम माय सब एरे लेंथ वुड बी व्हाट, सब एरे लेंथ वुड बी व्हाट, अभी क्या है 4 है अभी, ठीक है, अभी क्या है लेंथ वुड बी 4. अभी मैं मान के चल रहा हूँ कि जो मिनिमम लेंथ है उसको 4 अपडेट कर दो अभी, ठीक है. नेक्स्ट क्या होगा फिर, एज यू कैन सी सिमिलरली अगर मैं यहाँ से इफ आई स्टार्ट माई सवेरे फ्रॉम हियर 3 + 1 4 4 2 6 6 and 4 8. सो अगेन 4 तक तो नहीं मिलेगा बट 6 प्लस सॉरी या 3 + 1 4 2 6 6 4 10 हो जाएगा, ठीक है. तो 10 ही ग्रेटर देन इक्वल्स टू 7 होता है बट लेंथ वुड बी 4 अगेन. इफ आई स्टार्ट फ्रॉम हियर नाउ, ये 2 से सॉरी 1 से, इंडेक्स 2 है, सो 1 + 2 3, 3 and 4 7. So यहाँ से यहाँ तक the length is 3. So minimum length would become 3 because 7 is greater than equals to 7. ये true है, ठीक है. Next, if I start from here, so 2 + 4 6. 6 is not greater than equals to 7. 6 + 3 9. 9 is greater than equals to 7. What is the length? Length is 3. So this 3 will be still 3. If I start from here now, 4 say. So 4 लेस देन 7 है, प्लस 3 7 इज ग्रेटर इक्वल्स टू 7 है क्या? यस. व्हाट इज द लेंथ? 2 ओनली. सो मिनिमम लेंथ वुड बी अपडेटेड 2. आफ्टर दिस आई कैन स्टार्ट फ्रॉम 3 बट 3 is not greater equals to 7, so I have no more further items, so that's why answer would be 2. And here you can see the answer is 2, है ना. greater than equals to 7 मल्टीपल जगह बन रहा है बट जो मिनिमम लेंथ पे बन रहा है that is the 2. So I hope this is clear. And this must have given you some idea about the brute force also. Obviously, the brute force approach is nothing but you need to check every possible subarray, then calculate its sum and find the smallest one that meets the target. That's what we have been discussing here. सवेरे के सम निकाला है ना, ये सम था, सम निकाला, then we talked about the length and we're storing the minimum, है ना. That's what we are doing. We kept updating. So अभी क्या कर सकते हैं? Do I need to show you everything from scratch? नहीं ना. The similar thing we have seen in the previous question also. Just I need to show you the condition how to calculate the sum and keep track of the smallest length, है ना, whichever meets the target. And for dry run, I mean, you can probably catch things from here. So here, let's see. ये किया था, just start किया था. What I did on the previous page, that's exactly same is written more clearly, more neat and clean way here. Okay. So starting from 0th index 0, 1, 2, 3, 4, and 5. Okay, this is the start point and this is the end point, and would keep expanding. Why? Because you're expanding the subarray, है ना? So you can see here, and at whichever point, like here at the index 3, the sum became 2 plus 3 plus 1 plus 2. 3 to 5, 6, 7, 8 became 8, है ना? So from here the 8 is getting equals to 7, length is 4, you saved it, है ना, minimum को update कर दे because this is the first time you are exploring it, then break. You don't need to go any further, you don't need to go beyond this third index because इसके आगे sum सिर्फ बड़ा ही होता जाएगा, sum will grow only, and it is the minimum sum that you can get greater than 7, है ना, greater than equals to 7, बाकी तो सब greater ही है. That's why when you start from first index now, and we'll just starting from this first index. So 3 then 3 plus 3 is less than 7, 3 plus 1 है ना, which will become 4. 4 is also less than 7. Then plus 2, 4 to 6. 6 is less than equals to 7. 6 plus 4, 10. 10 is greater than equals to 7. So length is still 4, minimum is 4, break. Okay. Now here, starting from here, index 2, 1 less than 7. 1 plus 2, 3 less than 7. 3 plus 4, 7. It is greater than equals to 7, true है. And this time the length is 3, that's why minimum would also be updated. Update हो गया अब ये, ठीक है. Update it and then break it. Similarly, rest of the steps. And ultimately, my answer would be 2 only because the minimum became 2. That's why output is 2. Okay. So let's see its implementation now. Why I'm not showing each and everything repeatedly, because it's quite, you can say, repetitive now. We have been doing the same thing. So that's why I'm just gonna show you the exact part that is changing here from the previous question. So we are doing what? Target मिला है, arrays what we have got. We are keeping track of the minimum length by initializing it with some maximum value है ना, because this is the safe game है ना, कभी नेगेटिव से आपको डील करना होता है. It is always when you are dealing with tracking minimum things, so always initialize your minimum length tracker a variable with the maximum value of the integer. Okay, it will keep you safe. Now try every possible starting point. So that's why start is 0, start is going till all the items है ना, then current sum. So wherever I am starting with, I am keeping track of the sum of from that position, okay? Sum of current subarray. That's what I am doing here. Next, expand subarray from current start position. Expanding by putting one more pointer named end. End is starting from the start pointer and then end is running till the length of the array. Okay. Add current element to the sum. The more item I traverse in this subarray, I will keep adding them so that my current sum would be growing. And with every addition, I will check if my current sum is greater than the target or not, greater than equal to target or not, means it is meeting or exceeding the target. So whenever it is less, this if won't be working, if a statement won't be true. So this for loop would be reiterating continuously. है ना? Sorry. This for loop would be reiterating continuously. Okay. And whenever this is met, then it will start checking that current length equals to end minus start plus one, length निकाल लिया. Minimum length would get updated. If it is smaller, it will updated, and the current length is smaller, then it will be updated. And then there's no need to check longer subarrays from the start. Why? They will have larger lengths, but we want a minimum है ना. Larger length होगा वो तो मतलब exceed कर ही जाए some, so no use of it. That's why break statement is here. And ultimately, once all the arrays are traversed, all the subarrays are traversed, this whole for loop would be over. And after that, your final answer would be in this variable minimum length में, ठीक है? And that's why we are returning minimum length. Let's say if no valid subarray found, है ना, और कोई valid subarray था ही नहीं, then आपको return 0 करना है. कोई valid subarray नहीं था where your minimum length got updated, then minimum length would have the initially assigned value which was integer max value. So that's why if minimum length still have after everything is done the integer max value, then return 0, and if false then minimum length आप return कर जाओगे. Okay, this is just a classic if else condition written in just one line है ना. Multiple languages permit this kind of syntax, so you don't need to worry sir ऐसा क्या rocket science वाला concept लिख दिया यहाँ पे, ऐसा कुछ नहीं है. This is just simple syntax. Classic if else condition है, just written in one line because it was allowed by the programming language which is Java here. Okay. Now why this is inefficient? क्यों inefficient है? Again, repeated sum calculations. You must have seen हम सारे subarrays repeatedly उसके लिए calculate कर रहे हैं, जबकि we have pre-calculated it earlier ना. Sum of 3 1 2 calculated multiple times. No cumulative memory. We don't remember what we have calculated in previous sums है ना. So that's why it still explores many options. Even with early break, many subarrays are checked. Though we have got a lead कि हाँ इसके आगे जाना है, but yet we will be rechecking multiple subarrays. That's why. And that's exactly why big of n square is the time complexity here. All the subarrays are getting explored. Space complexity is order of 1 using constant extra space ना वो minimum के लिए use कर रहे हैं. and few other pointers, current sum like that, and current length. Okay, so that's why it is order of one only. But what is major concern here? This n square. This is polynomial time. We don't want it. This really affects the real world scenarios too much. And I will show you later, don't worry, in terms of figures, कि क्या exactly difference आता है. Okay. So let's quickly have this insight. Brute force versus optimal insight. है ना? What's wrong with the brute force? I have already discussed it, but let's repeat. Repeat some calculations हो रहा था. We have seen it already. No running sum. Why? Because we are recalculating again and again. Calculating again and again. We are not remembering anything, है ना? कोई running sum भी नहीं है. Because if you have seen, let's say my previous window was this much, है ना? And if my current window is moving one step forward, let's say 0, 1, 2, 3, 4 and 5, है ना? ये indexes थे. So running sum would be doing what? Running sum is equals to minus क्या होगा? Nums of 0 and plus nums of 5. Yes or no? Why would I add the rest of these items? These are the overlapping items. Yes or no? These are the overlaps. I don't need to recalculate them. That's why. Inefficient exploration था, ठीक है. We check 2, 3, 1, 2 and find it valid. Then we check 3, 1, 2, 4 and recalculate everything. Correct? क्योंकि 3, 1, 2 तो यहाँ पे overlap हो रहा है. Correct? That's what I have shown you here. Overlapping. The optimal insight. Maintain a running sum. That's what is gonna be the approach here. We need to maintain a running sum. Okay. As we slide the window. When we add a new element on the right, just add it to the running sum. When we remove an element from the left, just subtract it. Simple है. Subtract कर दो, remove कर दो तो. This avoids recalculating the entire sum for each array. Mathematically, it will be shown as if you had the window from I to J, and है ना, and if you are moving in the right hand side, means expanding in right hand side, expand in right hand side. So क्या हो रहा है? सम में आई टू जे माइनस वन जो था उसमें नम्स जे को ऐड किया है. ठीक है, अगर आप जे तक गए, आई टू जे जा रही है, आपका नया विंडो है जिसमें आप एक राइट हैंड साइड पे एक्सपेंड किया, यू हैव मूव्ड वन पोजीशन राइट हैंड साइड. So just before right hand side from I till j minus 1, you already had this sum. So just add one more item. And if you are shrinking the window है ना in left hand side, so जो आपके पास previous sum था उसमें से left का sum को item को minus कर दो. Okay. Shrink in left hand side. ये second वाले का है. This one and this one is right hand side. That's what the approach we are gonna use here. So let's see quickly. क्या यहाँ पे thought process हमारा? Understand the pattern. We need to find the smallest window with sum greater than equals to target. ये हमारा question था. Key insight क्या है? We need to expand the window until condition is satisfied. है ना? Why? Because this is what is it is written now. First target is this much. Expand the window until condition is satisfied, and once it is satisfied, then try shrinking from the left to find the minimal window. Minimal means इससे छोटा हो नहीं सकता है. Can't be smaller than this. इससे छोटा हो नहीं सकता है. That still satisfies the condition. So that's what we are going to do. First grow to achieve target sum, then shrink to find the minimal length window size. Minimal length window size क्यों? ठीक है. Why this works? By expanding right, we explore larger sums, है ना? Sum को बढ़ा रहे होते हैं right जाते हुए. By shrinking left, we find minimal windows. We never miss the optimal solution. That's why it works exactly. Okay. So algorithm क्या होगा? expand window by moving right pointer. When sum is greater than equals to target, record window size, and then shrink from left while condition is still satisfied. Continue until all elements are processed. This is what the algorithm is gonna be. These are the step-by-step rules that you need to follow in your code. Okay. So let's see very clearly. एक यहाँ पे ड्राई रन कर ही लेते हैं. Okay. So what is happening here? Right. यहाँ क्या होगा? यहाँ लेफ्ट हो गई 0th इंडेक्स पे 1 2 3 4 and 5 and right is also here. Okay, that is 0. Number is 2. Current number is 2. So current sum जो होगा वो भी 2 हो जाएगा because this is the only number. Left is 0 still है ना. Is sum less than target है? Yes, it is less than target है. So continue. I will move forward. यहाँ आ जाएंगे. Then 2 के बाद 2 plus 3 हुआ 5 हो गया. So current sum is 5. Left is still 0. Number current item is 3. Okay, right is 1. Sum is less than target. Less than 7. Yes. तो क्या करेंगे अभी? Continue करेंगे. Continue करेंगे. I will go here. So 2 plus 3 plus 1. 6 हो गया. Still less than 7. So I will move forward. है ना यहाँ आ गया. Then 2. 2 plus 3 plus 1 plus 2 कितना हो गया? 8 हो गया. है ना? So once it is 8, sum is greater than equals to target, greater than equals to 7 है क्या? Yes, it is. If it is, then minimum length would be what? Minimum length would be what? Exactly. मिनिमम हमने क्या लिया था मिनिमम लेंथ में? पहले तो हमने मिनिमम लेंथ ही लिया था जिसको हमने इनफाइनाइट वैल्यू दिया था, मैक्सिमम इंटीजर, देन राइट माइनस लेफ्ट प्लस 1, है ना? तो वही किया हुआ है, उसमें से जो मिनिमम होगा तो क्या आएगा? 3 माइनस 0, राइट इज एट 3, लेफ्ट इज 0 प्लस 1 4 आएगा. तो छोटा कौन है? इनफाइनाइट कॉमा 4 से छोटा कौन है? ऑब्वियसली 4. सो दैट्स आंसर वुड बी 4. मिनिमम लेंथ वुड बी 4, है ना? यहाँ पे करेंट सम तुम्हारा 6 था ही. नहीं नहीं, करेंट सम क्या हो जाएगा फिर? करेंट सम क्या हो जाएगा? ऑब्वियसली व्हाट इज द स्टेप? स्टेप क्या था? वंस यू रीच द टारगेट, व्हाट इज द स्टेप? Expand the window until the condition is satisfied, then shrink the left, है ना? Once you reach the target, record window size, then shrink from left, है ना? तो shrink करना है मिनिमल के लिए. तो हम क्या कर रहे हैं यहाँ पे? We are updating our current sum by removing the item at the left hand side. So क्या किया हमने? 8 minus item at left was 2, 6, है ना? और फिर हम क्या करेंगे? रिमूव करके जो लेफ्ट होगा उसको एक आगे बढ़ा दिया. So left is 1 now. Sum is less than target. 6 is less than 7. Yes. Exit this while loop. कौन सा while loop? Shrinking while loop. For shrinking. Because you need to remove multiple item ना. And you will be removing till you have achieved this much. कि अब तो मतलब उससे छोटे पे ही आ गए. That's why you can't. This step can't be done once. Multiple items are there. Okay. So that's exactly why it is gonna happen. Like see, left and right अब यहाँ अपनी अपनी जगह पे now. Right is 4, है ना? अभी तो right 4 पे होगा क्योंकि right प्लस प्लस भी किया होगा लास्ट टाइम से. तो राइट प्लस प्लस किया, जब एक बार लूप को आगे बढ़ाया, राइट प्लस प्लस किया तो 4 आ गया. तो करंट सम क्या होगा? लास्ट टाइम सम क्या हो गया था? 6 हो गया था. सो 6 प्लस 4 इक्वल्स टू 10 हो गया करंट सम. ओके, लेफ्ट इज एट 1. यस इट इज. सम ग्रेटर इक्वल्स टू 7 है. यस इट इज. सो व्हाट विल आई डू? वंस द टारगेट इज अचीव, नाउ आई विल ट्राई टू श्रिंक. श्रिंक करते हुए क्या करेंगे? श्रिंक करने के पहले मिनिमम लेंथ को स्टोर कर देते हैं. मिनिमम लेंथ वुड बी, लास्ट टाइम इट वाज 4, 4 comma right minus left plus 1. Right is at 4, left is 1. 4 minus 1 3 plus 1 4. So 4 अभी 4 ही रहेगा. Okay, no updates. Current sum equals to 10 minus 3 and 7. Why? Because target is achieved, length is stored, now shrink it. Continue करोगे ना shrinking. That's why. So current sum equals to 10 minus item at left. What is at left? Item is 3 equals to 7. 7 is greater equals to 7. Yes, it is. अभी भी है. ठीक है. So continue shrinking, but before that, continue to update the length. So updating the length again. Minimum would be now what? 4 comma last time it was 4. Right minus left. Right is at 4. Left is at 1 right now. So 4 minus 1. What would be the answer? 4 minus 1. 4 minus 1. But remember, अभी 1 नहीं कर सकते. बिकॉज ये 3 माइनस किया था ना, तो लेफ्ट से अपडेट भी तो होगा ना। 3 हटा दिया तो लेफ्ट कहाँ जाएगा फिर? यहाँ जाएगा। ओके, 2 पे। सो वंस इट इज सेकंड इंडेक्स, so 4 minus 2 plus 1 which will become 3। सो अभी क्या होगा, जो लेंथ है वो 3 आ जाएगा। ओके, वंस इट इज 3, देन what? आई विल कीप श्रिंकिंग इट until ये टारगेट से छोटा ना हो जाए, बिकॉज आई नीड टू फाइंड द मिनिमल। सो अगेन श्रिंक इट, सो करंट सम से फिर से माइनस होगा। करंट सम वाज 7, 7 माइनस आइटम एट लेफ्ट, लेफ्ट कहाँ है? 2 इंडेक्स पे आइटम इज 1, 7 माइनस 1 इक्वल्स टू 6 नाउ। वंस इट इज 6, 6 इज ग्रेटर इक्वल्स टू 7 है क्या? नहीं है। तो क्या करेंगे? अभी तो लेफ्ट को तो अब आगे जाना ही पड़ेगा। ठीक है, वहां तक हमने कर लिया था। लेफ्ट यहाँ आता है 3 पे, सिमुलेशन टारगेट है एग्जिट द वाइल लूप, ये लूप एग्जिट हो गया। ठीक है, नाउ लेट्स गो फर्दर। Left is at 3 index, right is at 4th index. Okay. Current sum is nothing but 6. ठीक, अब right को आगे बढ़ाओ। I will go here. Item is 3, 5th index पे। So 6 plus 3 equals to 9. Greater equals to 7. Yes. क्या करेंगे? लेंथ अब देखेंगे। लेंथ क्या हुई? तो राइट माइनस लेफ्ट, 5 माइनस 3 2 प्लस 1 3। सो 3 लास्ट भी था, अभी भी 3 रहेगा। ठीक है, दैट्स व्हाट इज हैपनिंग। लेंथ वुड बी 3। करंट सम हो गया, लेंथ 3 था। ठीक है, फिर अभी क्या करेंगे? अब यहाँ पे हम लोग वाइल लूप लगाना चालू करेंगे। कौन सा? करंट सम 9 माइनस 2, रिमूव कर दो अब लेफ्ट से आइटम, है ना। सो 9 माइनस आइटम एट लेफ्ट इंडेक्स, लेफ्ट पे क्या है? 2 है। 2 इज इक्वल्स टू 7, ग्रेटर इक्वल्स टू 7 है। यस। ओके, व्हाट इज द लेंथ? लेंथ वुड बी 5 माइनस 3। ओके, 2 आ गया प्लस 1, 3 आ रहा है, तो 3 अभी भी रहेगा, है ना। तो अब क्या करेंगे? फिर अभी श्रिंक करो। ठीक है, श्रिंक किया अगेन, कंटिन्यू श्रिंकिंग व्हाट इज रिटन हियर। फिर से श्रिंक किया ना, तो क्या होगा? लेफ्ट अभी इधर रहेगा, यहाँ पे। एंड दिस टाइम व्हाट आई एम डूइंग, व्हाट आई एम डूइंग दिस टाइम। समझ गए टारगेट है, दिस टाइम व्हाट आई एम डूइंग। आई थिंक 9 माइनस 2 जब 7 आ गया था, लेफ्ट वहां 4 पे था। ठीक है, हाँ रिमूव करें बस। वी मिस कैलकुलेटेड, है ना यहाँ पे। सो व्हेन दिस आइटम 2 वाज डिडक्टेड, है ना, 9 माइनस 2 7 आया था, तो लेफ्ट भी तो अपडेट होना था। तो लेफ्ट यहाँ आ जाएगा 4 पे, 4th इंडेक्स पे। फ्रॉम हियर इफ आई कैलकुलेट द लेंथ, 5 माइनस 4 1 प्लस 1 2 आएगा। सो लेंथ ना अभी 2 हो जाएगा। ओके, न्यूमरी हमें ऑलरेडी मिल गया है, अभी भी वॉशिंग करना थोड़ा मुश्किल है ना। यहाँ से एक बार मिल गया, बस एक और बार और जाएगा। सो आफ्टर दिस वी अपडेट लेंथ इक्वल्स टू 2। आफ्टर दैट क्या करेंगे? फिर हम क्या करेंगे? फिर अगेन 7 जो करंट सम था वहां से 4 को माइनस करेंगे, बिकॉज इट इज पॉइंटेड बाय द लेफ्ट पॉइंटर। सो 7 माइनस 4 विल गिव मी 3। ग्रेटर इक्वल्स टू 7 है? नहीं है। सो एग्जिट द लूप। ओके, आफ्टर एग्जिटिंग द लूप, माई राइट वुड बी, राइट पॉइंटर वुड बी आउट ऑफ बाउंड, है ना, क्योंकि अब तो ट्रेवर्स कर नहीं सकते। सो द होल प्रोसेस इज ओवर, एंड वंस द होल प्रोसेस इज ओवर, होल array is traversed, I am left with length equals to 2 as the most optimal. So that's why I put it to 2. Let's see the code here quickly. Target array is given, left pointer, left boundary of the current window, current sum, running sum of the current window, minimal length, minimum length. So track minimal length. That's why integer max value we have taken. Expand window by moving right pointer. So right pointer is starting from 0, right is going till the end, and right plus plus. Okay. Add current element to running sum. करंट एलिमेंट को रनिंग सम में ऐड किया। ठीक है, कुछ मिला। while current sum meets or exceeds target, try to shrink window। ठीक है, वी यूज while not if to find a minimal valid window, क्योंकि मल्टीपल आइटम्स को आपको रिमूव करना हो सकता है, नॉट दैट्स नॉट इफ। सो while में अगर, because see while is what, it first checks the condition, if the current sum is greater than equal to target, then only it is gonna run, otherwise it won't be। so that's why while current sum is greater than equal to target अगर है, तब तक update minimal length found so far। so minimal length equals to mat.min, minimum ही चाहिए, already value of the minimum length, comma, compared with right minus left plus 1 means current window size, nothing but current window size। okay, Now remove leftmost element from sum and move left pointer, है ना. अब कैलकुलेट कर लिया लेंथ. सो कीप श्रिंकिंग, है ना. कीप श्रिंकिंग, श्रिंक करते रहना है. So that's why हमने उसको रिमूव किया एंड लेफ्ट को प्लस किया एंड देन दिस while loop will reiterate. Continue shrinking to see if we can get even smaller window. And जब ये satisfy नहीं होगा then this for loop would be running over again, है ना. reiterate होगा ये for loop आपका. ठीक है. So if no valid subarray found, return 0. Otherwise return the minimal length. Return 0 करने के लिए क्या करना पड़ेगा? If you have found no valid subarray, then the initial value of the minimum length would still be retained, है ना. तो अगर ये true है तो आप 0 रिटर्न करोगे, अदरवाइज minimum length जो ऑलरेडी अपडेट हुई है वो रिटर्न होगी. So that's how this problem would be solved. Okay, that's how this particular problem would be solved. So what about the time complexity now? Now you can see that combinedly your left and right pointers can traverse, though it is a while loop, nested भी है ना. बट ये क्या कर रहा है, ये लेफ्ट पॉइंटर को फॉरवर्ड कर रहा है, रिमेंबर. एंड फॉर लूप आपके राइट पॉइंटर को फॉरवर्ड कर रहा है. एंड बोथ आर गोइंग इन द सेम डायरेक्शन. Combinedly they can traverse the array twice of n times. That's all, nothing more than that. So that's a big of n only, the time complexity. Space complexity क्या होगी? Constant. Why? Because we are not using any extra space, है ना. सिर्फ वेरिएबल्स यूज किए हैं. So here is a comparison. So right pointer traverse order n, left pointer also traverse entire order of n. Each element added once and removed once, amortized twice of n. So big of n you can call it. Why not n square? While loop doesn't make it order n square. Each element processed at most twice, added by right moves and removed by left pointer. Okay, that's why. That's what I told you earlier. Left pointer never goes backward. That's one of the major reason why you can't call it key nested है directly, and that's why we need to say कि order n square जा रहा है. Okay. Now about the space complexity. Order of 1, so only using a few variables, no extra data structures, that's why it will be constant. So starting window order n and order 1 space. Okay, I hope you are getting this. So complete complexity comparison is here. Longest unique subarray is first problem, then second problem minimum subarray sum. As you can see, कि let's focus here, है ना. Polynomial time से we have reduced it down to linear time. Here again polynomial time to linear time. Okay. So performance analysis for n equals to 1000. So brute force would be n square था. So 500,000 operations हो रहे थे. अब वो linear में आएगा तो कैसा होगा? Suddenly it will be 2000 operations. So improvement क्या है? 250 times faster है. Can you believe? It's incredible speed. We have means though it will be looking like simple square, but if it is linear, that's how fast it is. So that's why you need to optimize. But again, this doesn't mean that brute force will be completely, I mean, वो important नहीं रह जाता, ऐसा नहीं होता है. तो build intuition about the problem, ये आपको help करता है brute force, provide correct solution, okay, and then help you understand what optimal solution improves and useful for small inputs where simplicity matters. So simple solution just दे सकता है आपको. So always first focus on the brute force, then move forward. Okay. Let's talk about the pattern questions, है ना. तो कब यूज कर सकते हैं हम लोग वेरिएबल स्लाइडिंग विंडो पैटर्न वन. Longest subarray with property x, that's what we have seen today. Expand right until property violated. Adjust left to restore property, that's what we did in the very first problem. Track maximum length, and example क्या था क्वेश्चन का that we solved, longest subarray with unique elements. Okay. Pattern 2 would be shortest subarray with property x. वो property क्या होगी? So क्या हो सकता है कि expand right until property is satisfied. Okay. Shrink left when property is maintained. The second problem. Track minimum length, minimum size subarray sum, है ना. ये second question का था. If we were to put it in words. Pattern 3, subarray with exact key property, है ना. एक तो maximum देख लिया, minimum देख लिया, exact key property है. So more complex होती है, usually needs frequency counting, है ना. Examples, subarrays with exactly k distinct elements. This is what I really want you to think about it, think of it, and try to solve on your own also, है ना. We'll discuss later. Okay. Common edge case क्या होता है इसमें? That's what mostly student misses while solving. So empty array या no solution भी हो सकता है. You need to handle it. That's what we handled by using the integer max value. Okay. Edge case 2, single element solution भी हो सकता है. Output 1 ही हो रहा है. तो algorithm handles naturally. एक बार देख लो आप डायरेक्टली, है ना, सब कुछ रन करने की जरूरत नहीं है। केस से नेगेटिव नंबर्स, अभी तो ये सही दे रहा है बट वी नीड टू बी केयरफुल अबाउट नेगेटिव नंबर्स इफ इट इज ऑलरेडी कंस्टेंट्स आर गिवन इन द प्रॉब्लम स्टेटमेंट कि नेगेटिव भी हो सकता है, नेगेटिव नंबर्स आर आल्सो पॉसिबल, देन वी नीड टू बी वेरी वेरी केयरफुल अबाउट इट। ओके, नेक्स्ट कैन बी ऑल एलिमेंट्स आर सेम। सो रिपीटेड कैलकुलेशन होता है कई बार। ओके, सो probably you can just think of this case also and try to run your solution how you can optimize it, है ना। so no issues upon here also, बहुत हैवी नहीं है but it's just you can't miss them। okay, now real interview में कौन से क्वेश्चन पूछे जाते हैं similar to this? So real interview questions and variations would be, in Google the variation was longest subarray with at most k distinct elements, okay, which I personally feel that if you have learned what I have taught today, so you'll be able to solve by applying that idea here also. A little modification would be needed. Next variation was asked in Amazon, minimum window that contains all characters of a pattern. Next was in Microsoft, find all subarrays with sum equal to k. Okay, so that's what also you can solve on your own. Meta variations, meta में जो variation आता क्या था? Longest contiguous subarray with equal number of zeros and ones. है ना, some modifications are needed, okay, but the heart and soul of the problem is same, है ना, जो sliding window की है वो same है। So why these patterns matter? Build directly on today's concept, पूरा main heart वही है। Test understanding of sliding window fundamentals, very common in technical interviews, which solve real world data streaming problems। At the very first day about sliding window I told you, जो लाइव स्ट्रीमिंग होती है, जो भी टाइम फ्रेम से काम होते हैं, everywhere sliding window is being implemented ना, तो डेटा स्ट्रीमिंग प्रॉब्लम्स को भी सॉल्व करता है। की टेकअवेज वुड बी conceptual understanding, variable windows, expand contract based, है ना, on conditions है, hash map है, we have, I think we have already done this, है ना। तो फ्रेमवर्क आप देख सकते हो, आइडेंटिफाई स्लाइडिंग विंडो काम करेगा या नहीं करेगा। Then you need to choose expansion and shrinking strategy, select appropriate data structure, handle edge case, and then analyze complexity। Okay, so let's come quickly to the preview and continuous learning. Tomorrow we'll be solving hashing pattern deep dive to some variations and optimizations. Okay, moving forward in the same direction. Okay, literally. So subarray sum equals k problems and the frequency counting techniques. Why this matters? Hashing complements sliding window knowledge because sliding window is a technique आप कर रहे हो, but the constraints that are given in the problem, okay, are really being handled by the hashing, as you have seen in today's problem also, and further problems also we'll be seeing। Okay, essential for some related problems, very high frequency in interviews। interviews कल तो most you can say favorite problems होती हैं इन पे, पक्का पूछते हैं। Okay, build on today's hash map uses, देखेंगे। Test your understanding, I will leave you with some questions that you should answer to yourself, okay, and then challenging problems also that you can try to solve। What happens if we use hash set instead of hash map for the longest unique subarray problem? Remember hash map use किया था first problem में, hash set अगर use हो तो क्या difference आएगा? Figure it out, okay? Some challenges are there। How do we use while loop instead of if in the minimum subarray some problem? This is kind of explanation that you need to give to yourself after looking at the answer, है ना, क्योंकि I mean most instinct way में if a statement would be coming to your mind, but instead of if you use the while loop, it will also do the job in a better way। Okay, how would you modify the longest unique subarray solution to handle at most k duplicates? Question same है, एक extra constraint है, try to solve it। Okay, what's the time complexity if you use tree map instead of hash map? So to answer this, you first need to go and look into Java documentation of the collections library and see what a tree map is, how you use it, and how it is different than hash map. Then you can probably find the answer। Okay, now challenge problems। Can you solve longest subarray with sum less than equals to k? Plot twist कर दिया है। How about number of surveys with sum exactly k? ये हमने previous slide पे भी देखा था। Okay, so try to solve these versions as well। Final motivation, of course the series are I mean continuous series of lectures है ना, तो long तो होती ही हैं, but just to give you little motivation कि हमने कितना cover कर लिया है, so you will see that first every detailed try then every complexity analysis, every edge case you handle makes you more interview ready, क्योंकि interview में यही तो काम आता है, सिर्फ याद करना solution is not enough। So today you just didn't learn algorithm, you learned how to think like an expert problem solver। You learn to build your own thought process, है कि नहीं? Build your own thought process कि सोचना कैसे है. That's what really matters. That's how you will be able to solve new problems as well, which you have never seen before. Though heart and soul same होता है, but problems थोड़े से different होती हैं. So your journey to mastery में अभी तक आपने क्या किया हुआ है? As fundamentals and two pointers we have covered. Fixed sliding window is covered. Variable sliding window we have covered today. Rest we will be covering from next session onwards. Okay, so please stay tuned, be in touch, and if you have liked the sessions till now, if they are really meaningful to you, because we are covering the interview patterns, questions directly, showing you how things work, not just by showing कि exactly कैसे काम करें, instead giving you hints and pointers around how you can learn the patterns. Okay, that would really help. So if this content is meaningful for you in any aspect, then please do like, share, and subscribe to our channel, and be tuned to our channel for more updates. Okay, so thank you for this session. Thank you, everyone. Let's meet in next session.